Hi everyone. Today we're doing notes for 11.8 expected value. Expected value is the mathematical way to use probabilities to determine what to expect in various situations over the long run. Expected value is used to determine premiums on insurance policies, weigh the risks versus benefits of alternatives in business ventures, and indicate to a player of any game of chance what will happen if the game is played repeatedly. The standard way to find expected value is to multiply each possible outcome by its probability and then add these products. It is equally probable that a pointer will land on any one of four regions, numbered 1 through 4. Find the expected value where the pointer will stop. So the probability of each region is going to be 1/4 because it is equally probable. So my expected value, I will do 1 times 1/4 plus 2 times 1/4 plus 3 times 1/4 plus 4 times 1/4. If I simplify this is 1/4 plus 2/4 plus 3/4 plus 4/4, which gives us 10/4 or 5/2 or 2.5. A fair coin is tossed 4 times in succession. Find the expected value for the number of heads. So you can use the table here at the right, and I would like you to try this one. Okay, so our expected value, we have 0 times 1/16 plus 1 times 4/16 plus 2 times 6/16 plus 3 times 4/16 plus 4 times 1/16. If I add this up, we have 0 plus 4/16 plus 12/16 plus 12/16 plus 4/16, which gives us 32/16 or 2. Okay, an automobile insurance company has determined the probabilities for various claim amounts for drivers ages 16 through 21. Our example 3 in the text uses the following probabilities. What if the claims of $0 and $10,000 were reversed? So in other words, we're going to switch these. I'm going to change this probability to 0.01 and this one to 0.70. Thus, the probability is just how we switch it. $0 claim is 0.01, $10,000 claim is 0.7. So calculate the expected value and describe what this means in practical terms. So I want you to take a minute and do this, please. Okay. So we have 0 times 0.01 plus 2,000 times 0.15 plus 4,000 times 0.08 plus 6,000 times 0.05 plus 8,000 times 0.01 plus 10,000 times 0.70. And if we calculate all of this, we get an expected value of $8,000. And so what this means is, in the long run, the expected average cost of a claim is $8,000. So B then says, how much should the company charge as an average premium so that it does not lose or gain money on its claim costs? So if the insurance company is expecting to pay out $8,000 per claim, then they should charge $8,000 for a premium. Therefore, they're not losing or gaining money on each of the claim costs. Business decisions are interpreted in terms of dollars and cents. In these situations, expected value is calculated by multiplying the gain or loss for each possible outcome by its probability. The sum of these products is the expected value. So, the SAT is a multiple choice test. Each question has 5 possible answers. The test taker must select one answer for each question or not answer the question. 1 point is awarded for each correct response, and a quarter point is subtracted for each wrong answer. It's not like that when you guys take it now. However, when I was in high school and we took it, this was the case. No points are added or subtracted for answers left blank. The table summarizes the information for the outcomes of a random guess on an SAT question. Find the expected point value of a random guess. Is there anything to gain or lose on average by guessing? Explain your answer. I would like you to do this one, please. Okay, so our expected value, we're going to do 1 times 1/5 plus negative 1/4 times 4/5. So that gives you 1/5 minus 1/5, which is 0. So is there anything to gain or lose? This is no. There's nothing to gain or lose by guessing on average. Now, obviously, this might differ from person to person, but on average, there's nothing to gain or lose by guessing. Okay, expected value can be interpreted as the average payoff in a contest or game when either is played a large number of times. To find the expected value of a game, we multiply the gain or loss for each possible outcome by its probability, and then we add the products. A charity is holding a raffle and sells 1,000 raffle tickets for $2 each. One of the tickets will be selected to win a grand prize of $1,000. 2 other tickets will be selected to win consolation prizes of $50 each. Fill in the missing column in the table, then find the expected value if you buy 1 raffle ticket. Then we have to describe what this means in practical terms. What can you expect to happen if you purchase 5 tickets? So first, let's fill in the table. Now, these are being sold for $2 each. So if you win the grand prize, you win $1,000. But you purchase your ticket for $2, so your gain is $998. Consolation prize, similar. Consolation prize is $50. but you purchased your ticket for $2. So your gain is $48. If you win nothing, you purchase the ticket still, so you have a loss of $2, and we indicate that with a negative. So let's find our expected value using the probabilities. Go ahead and do this, please. Okay, our expected value, we have 998 times 1 over 1,000 plus 48 times 2 over 1,000 plus negative 2 times 997 over 1,000, which gives us an expected value of negative 0.90. So what this means is, in the long run, you can expect to lose 90 cents per ticket on average. What can you expect to happen if you purchase 5 tickets? So I could do 5 times negative 0.90. This is negative $4.50. So you would expect to lose $4.50 when you purchase 5 tickets. But I'm going to put this in red. You have to be careful with expected value. Because think about this. If you have 5 losing tickets, you lose $10, right? It's not the negative 450. If you have 5 losing tickets, you actually lose $10, right? But if you have the consolation ticket, and 4 losing tickets, well, that actually comes out to you winning $40. Okay, so just have to be careful. Expected value gives you an average amount, but the actual amounts may differ depending on if you're winning or losing. All right, last one. In a game of 1-spot Keno, a card is purchased for $1. It allows a player to choose one number from 1 to 80. A dealer then chooses 20 numbers at random. If the player's number is among those chosen, the player is paid $3.20, but does not get to keep the dollar paid to play the game. Find the expected value of a $1 bet and describe what this means. So go ahead and do this one, please. Okay, so I'm going to start by making a little chart first. So our outcome, we're either going to win, meaning your number's chosen, or you're going to lose, which means your number is not chosen. So if you win, we're going to gain $2.20, right? Because the players played 320, but they do not get to keep the dollar paid to play. So it's actually a gain of $2.20. And if you lose that dollar you paid to play. Here's our probability. It says that a dealer chooses 20 numbers at random. So our probability of winning is 20 out of 80, which is 1/4 or 0.25. Probability of losing is 60 out of 80, which is 3/4 or 0.75. So to find the expected value, we have 220 times 0.25 plus -1 times 0.75, and this is -0.2 or -20 cents. So on average, in the long run, you would expect to lose 20 cents on each $1 bet. And that is the end of our chapter 11.